It's a great pleasure to be told in 5 seconds warning that I'm introducing Gernot Wagner, but it's really a great pleasure to have Gernot Wagner here. I didn't review this, so this is a memory test, but Gernot got his undergrad at Harvard and in econ. He told me that he got flown out here but decided not to come. and did academic econ work, but then went on to be the chief economist in environmental defense, doing a bunch of applied work on a range of different topics, including very early on being one of the people who tried to get environmental defense to think about climate engineering. Then around 2000, and when did I hire you?
When was the Paris Agreement gavelled into place?
It's a memory test I'm failing. I'm short of sleep. Yeah.
So you were in my living room on that afternoon in summer, right?
Yeah, so this would have been like 2014? 15, okay, yeah. Got it. So then Gernot came, soon after I came to Harvard, when I really built up the Harvard program. Gernot and I got working together with him as the executive director of the Harvard program. And starting a few years ago, again, I don't remember exactly when, Gernot has been at the Columbia Business School, where he's basically running their clean tech program, and instead he has the course that's got the biggest course or something. You can see I didn't plan this.
I co-teach the most popular elect.
Co-teach the most popular elect. Okay, and it's great.
Happens to be climate.
And Gernot, welcome. Great to have you.
Thank you.
Thanks, David. Thank you, David. So I was never the chief economist. I was the lead economist, but that's a difference without whatever at EDF. But actually, they make a big deal out of that, but thank you. The one thing David didn't say, really, my entire academic career was basically I've been the plus one. My gynecologist spouse, it's fun to take a break between those two. She's the one institutions want, and then NYU creates a post for me, basically. So I'm happy to say now that my move from NYU to Columbia was the very first time. Siri, my wife, is still at NYU. I'm at Columbia. And I'm at a business school, which is the worst possible place to be doing anything related to climate engineering, to the SRM side of climate engineering. Right? And I'm saying this not to derail this from slide one, but the context in some sense, right? The latest and greatest news on this, not greatest, but the Stardusts of the world, 60 million in VC funding later, and we are basically, right, sort of the broader solar geoengineering, climate engineering, SRM universe is forced to be on the defensive, as it were, without inviting that, which might be a first, right? So the fraught conversation has been with us for a while. This time around, it's different, and this is now maybe the EDF history. So David, I'm not putting you on the spot now, but remember when we first met, very first time?
I first went to EDF in 2002.
Yeah. So my very first act at EDF, one of the very first ones at EDF, Environmental Defense Fund, by now $1 billion Enviro Group, was to organize a science day for the EDF board, where David gave the keynote, actually one of the 6 keynotes, to basically, as far as I can tell, for the very first time, introduce to EDF the idea that there is this thing called solar geoengineering out there. And EDF was never sort of the Greenpeace of the spectrum. Always the suits inside, right? Polar bear suits outside to allow the suits to then show up for the negotiations kind of thing. So always the corporate sellouts among the enviros, if you will. But we did not have a stance on nuclear power at the time for those same reasons, right? Should a place like EDF get into this general idea of, right, should we take this with? So that was one of my first acts. One of my last acts of EDF, 2016 now, 2015, 2016, was to write the memo that then after board approval and so on ended up as a public statement on the EDF website saying EDF as an enviro group is in support of small outdoor experiments, research on this topic, and so on. And okay, that's the span of a decade or so, ancient history by now, if you will. But as a sign of how this conversation has moved on, we are no longer questioning whether this is a topic one ought to engage in for all the obvious reasons. Okay. That said, okay, and this is the, okay, so I spend, whatever it is, 18 hours with my MBA students at Columbia, teaching them about climate and business. And there's literally 15 minutes of this on SRM. And the first sentence, right, so you guys are the worst possible crowd to be having this conversation because the last thing I want you to do is go out and start an SRM business writ large, right, Stardust style. Might be a role and so on, but the sort of things that MBAs are good at just isn't needed in this space because it's not the question of, right, how do we decrease the cost of, climb the learning curve, slide down the cost curve, carbon removal? Sure, we need that. Solar geoengineering? We don't. If anything, it's too cheap, which in a rational world isn't a thing, of course. If it's too cheap and you don't like it, just don't do it. But, well, newsflash, we don't live in this rational world. And to fast forward through this, and this is now the origin of this, which very much, as you can tell, there's always a David connection here, but when was the History and Prospects paper review article? 2000. Year 2000, published in 2000, right? One of the most cited papers in this field. And, okay, back then, right, we knew a bit less than today. 1,000 peer-reviewed papers earlier than today. We already knew, or David wrote about, that sort of here's some canonical facts of SRM. And one of those, there's some economists who then got into the game, is sort of a version of this, which is there is a problem out there, the free rider problem, welcome to climate change. Everything we think we know sort of reverses when it comes to SRM, right? The point is not to motivate more people to do more, although, right, in a rational sense, of course, reason for research to help guide, of course, but again, big picture, if anything, it's to stop people from doing too much, too soon, stupidly. And maybe this, stupidly, right, this is of course where research comes in, where a university setting comes in, and where it is key now to help. So first of all, to take a step back from what I just did, like the hand-waving generalizations, right, and actually get down to business and start figuring out, okay, what are the unanswered questions? What are the interesting bits where some new idea, beautifully executed in a peer-reviewable setting, can really help this conversation forward. Okay, back to this. Full disclosure, this has already been published. So I welcome all feedback and any and all. Sorry, won't be able to fix this retroactively anymore. It literally came out a month ago at this point. And all the credit goes to Miranda, as so often. She's a second-year grad student. any blame and/or questions, my email is up there. 2 words on the framing of this exercise. And even this is carefully chosen, right? This is the URL shortcut that guides you to my website to then go to, the nature.com thing. But I, at least at the time, thought, and that was a couple months ago, still think, that a way to be productive in these conversations is to emphasize that, trust us, we get it. There are issues, problems, concerns. Drawing into audiences who would not click on something that says, SAI as solution or whatever. While very much, once you have people's attention, thank you for joining this talk, then be able to actually hope to convince your audience, the audience, that at the end of the day, this very first initial, not informed by anything other than it seemed to sound good at the time, and Marty Weitzman wrote a technical paper a couple years after that proved that with equations. It is true that whatever that is, SAI now, so stratospheric aerosol injection, is really, really cheap. I will go through some fairly in the weeds details of why it may not be as cheap as expected, why it may not be as simple. But, okay, 6 30-minute conversations later, those things seem to be fairly well known among people who do this for a living. For example, this is also a bit of history now, almost a decade at this point. And Wake Smith has done lots and lots of more work and is still looking at ways to add to this conversation by doing more than the simple, let's figure out whether it is possible that existing planes fly high enough and do this efficiently and so on. This is a sort of techno-economic analysis, right? You need a spreadsheet for this that isn't going to get you tenure anywhere, but may actually be more productive to advance the conversation than most other things one can do in this space. Yes, I'm biased here. Whether 1.4 is right or 1.5 doesn't matter. Let's start with that. This is 1.4-ish, whatever, $billion per megaton of SO2 per year. And there's an implication. So what does that mean for how much warming would be offset by this? Well, it's as little as single-digit billions of dollars, maybe low tens of billions of dollars. As long as the order of magnitude is right for each degree centigrade of warming, that grand conclusion is still true. And this is the real conclusion from all of this. And in some sense, we're living through this right now. Right? ScopeX may not have ever flown. There's a long story, lots and lots of long stories there. There is this, for better or worse, startup that just raised another $60 million that isn't deploying, but is pushing, shoving, dragging the rest of us with it in this conversation in a way that very much feels like this, in a broad way. And I'll get to the paper in a second, just two more sentences on this. I think the key bit now for the rest of us in all of this, in whichever way, shape, or form we are operating, is a place like Stardust, at the very least, gives the rest of us an operating space to then be doing, everyone does the serious research, of course, right, to be doing this research without having the direct target on their back, without basically having to justify on a daily basis one's interactions with, experiments on, time spent on, the sort of questions that then may actually be the really interesting ones that help refine what it is that we are talking about when we say stratospheric aerosols. Right, so yes, I personally am thankful to Stardusts, the Stardusts of the world, for allowing that, despite the fact that in a news cycle sense, they might be doing more harm than good as we speak. Okay. Let me pause there and try to convince you that this paper deserves being published. Okay. So the starting point in many ways is that, and opinions differ here, that we all seem to have a sense of what the idealized scenario ought to look like. Right? Whether this is literally, on some blackboard, whiteboard, or for that matter, there is some modeling, and yes, plenty of climate model runs these days, of in the idealized fashion, you turn down the solar constant and don't do anything else. We don't actually model the particles. And now let's approximate that in whatever model setting, real or otherwise, one operates. What we do know, I think we know, and please, this is unusual for, so I've given 2 econ seminars, I've never gotten beyond slide 2. Happy to take questions as I go along. We can all agree on certain things, right? So we want to minimize certain aspects, maximize certain others. And, minimizing, stratospheric heating is bad, or a negative side effect. It may not matter all that much at the end of the day, but it's certainly not something, it's one of the many, it's one of the 26 by now, whatever, Alan Robach risks from way back when. One of those that at the very least one ought to consider. And again, it may not matter at the end, but ideally we can agree that we want to minimize. Same with ozone interaction. Right? One of the reasons why sulfate aerosols may not in fact be the quote-unquote best, at least in the lab setting, because, well, you add an acid, funny things happen. Have you considered adding a base? Never mind that at the end of the day, sulfate aerosols might be the winner by default, simply because, there are risks, there are trade-offs, but we know much, much more about them than we will ever do about some patented particle given to us by some startup. Okay. This is what we want to minimize. Here's what we want to maximize. Many other factors missing. I see David frown for the first time, which is. But there are certain things we want to, with its own trade-offs, by the way, right? Like if we create the particle that lives forever, that may not be good for all the obvious reasons. It might be a feature that sulfate aerosols drop out after whatever it is, 18 months or so. But 19 months is better than 18, at the very least. And even if we disagree with the specifics here, there are certain things we do want to maximize. Okay, so it's an optimal control problem. Okay. Abstract, of course. But there are certain things on the dial we want to optimize for on the technical side of things. And yes, there are certain things we want to optimize for on the human, societal, governance, economic, in quotation mark. And there are Right? These are two independent dials. There might be some interaction effects. There are now trade-offs in how much emphasis we put on certain technical, scientific, natural scientific constraints versus whatever the social sciences do. And there are some buzzwords, some are more relevant, some are less relevant, but the moral hazard thing is out there, for example. And no, it's not moral hazard in the strict economic sense, but actually, yeah, it has a flavor to that. Right? Just quickly, step back. Everyone knows what I mean by moral hazard, right? And by the way, some of that is optimal. Right? So put on your seatbelt, drive home faster. Getting home faster is good. Some of those trade-offs are rational, and some are just not. Okay, in this case, right, moral hazard is the wrong term. Mitigation deterrence. The more we talk about solar geoengineering, the more we may detract from the need to cut emissions in the first place. Okay, the opposite might hold too, right? The more we talk about it, the more we emphasize that there's a climate problem, and the more we elevate the broader conversation. And of course, the trick is to get from one to the other. Just one of many, many things that then get subsumed under this all-encompassing term called, let's figure out how to govern this system. This is, of course, also where the science fiction books are written and so on, right? So let's figure out the scenarios, the somewhat realistic deployment scenarios.
On the moral hazard issue, or on the mitigation deterrence issue,
Yes.
do you learn anything you can extrapolate from the discussions about adaptation, which was, in a similar sense, like the thing we don't talk about in international negotiations until very recently? Like, I get the sense that now a robust discussion on adaptation has not deterred mitigation to any degree whatsoever, because there was no mitigation really happening. So, like, do you extrapolate in the same way, or do you see this qualitatively differently in impacting that mitigation discussion?
I think qualitatively it's exactly the same. And maybe, so when you said that, right, so there's, I don't know how many conversations, lunches or whatever, right, so we've had, so here's the Enviro experience in some sense. Al Gore was on the record in the early 90s to say, let's not talk about adaptation, let's solve this thing once and for all. Let's get Kyoto done. Anyone remember that? 1997, right? That was supposed to solve this. That was, anyway, some issues, but let's push it over the top, get the mitigation thing figured out, and then, of course, we know things are bad enough already. Okay, fast forward, early 2000s, okay, Enviro Group, right? It didn't take long in the early 2000s for the EDFs, NRDCs, Sierra Clubs, Greenpeace, or whatever of the world to figure out that polar bear family looking left toward donation button actually motivates more people to care as opposed to looking right away from the button, right? Like there's all of that too, of course. But, right, like the poor polar bear family and look the need for adaptation and look things are hitting home already. And the modern day version is, actually as of 2 weeks ago, no longer, but you can go to Zillow, right? Saturday night, real estate porn, right? Like figure out like sort of, yeah, whatever. Look up your property and your neighbor's property. And you got the climate risk score. Is that motivational for us then to want to do more on the mitigation front? Or does it demotivate? And I think the short version is quality, like it could do either depending on how you frame it. And newsflash, when Frank Luntz writes the memo for George W. Bush in 2001, he emphasizes the demotivational aspect, the deterrence aspect of it. When the other side tries to do the same, we figure out how to actually get people to take it more seriously. And so I wished I now didn't delete those slides before. The most famous sort of entry in this, Christine Merck et al., German sociologist, social scientist, 2016, I think, a long time ago. She famously put 600 Germans in a lab or online, but revealed preference. 200 Germans get told climate change is real. 200 Germans get told climate change is really real, as in, this is really bad. And 200 Germans get told that climate change is real, and there's this thing called SAI. Actually, pop quiz, who is most motivated to put more of their own money toward offsetting their own emissions? The third group, right? Statistically and economically significant, and so on, and right. So this is real. There's 20 euros involved, and so on, and whatever you think of offsets. But yeah, those 200 Germans are much more likely to spend more of those 20 euros on offsetting their own emissions. Okay, so at the very least, it tells you, at least for the Germans here, there's a way to, people who already know that this thing is real, there's a way to frame this. Okay, so this is now, actually, that slide I might have. So there was an N of 600, in part because of the Harvard program. And I should say this particular thing mentions a large US environmental group without ever mentioning which group that is. We have an N of 300 plus thousand. And we basically, we spam people with Facebook ads, essentially. So this is Christina Merck and me, published a year ago. And it turns out that you can basically get whatever answer you want, is the short version. And a non-result is unpublishable, turns out, or it's very difficult, right? So essentially what we are trying to do then is to say, okay, let's frame it as, right, like if we figure out what is a reasonable way to talk about solar geoengineering, yeah, when you do that, you get reasonable results, right? While, yes, not part of this here, but actually, no, it is. That sort of madman thing. I think one of these is like we got a picture of the ex-Exxon CEO, then the Trump one's Secretary of State. Some quote he actually did say, kind of along the lines of, right, climate is an engineering problem, and we fed into the perception that what he meant was solar geoengineering, which he didn't, turns out. But okay, fine. We're trying to trick people into thinking that there's some madman out there who is just going to solar geoengineer us out of this problem. And in that case, yeah, okay, so, I'll let you interpret the statistics, but there is a way to, in fact, get now a liberal-conservative split on the one hand, and you can get to mitigation deterrence. You can get to the exact opposite of mitigation deterrence. And my grand conclusion of this, at least, is if you give this tool to people and they use it responsibly, it is possible to basically use the conversation on solar geoengineering in the broadest sense to, in fact, motivate more people to do more on climate change. While also not going all the way, which would be basically, right, like to present solar geoengineering as this evil, and therefore we install solar panels in order to avoid having to do solar geoengineering, right? That would be stupid too, because it turns out that's not, in fact, rational to conclude from any of this. But in some sense, okay, that would be our worst problem, right? People want to do more solar engineering and less solar geoengineering. Cool. Install solar panel as a garden fence and see, right? Like, yes, go do that too, of course. We need much, much more of all of the above. Okay. Thanks for the flashback. Yes?
Doesn't what really matter, like how these preferences aggregate and affect the actual judgments and
Of course.
so have you
Yes.
in terms of like elites or
Actually, any political scientists here? Like, as in, you play one on TV, or that counts. Okay, fair, right? So, okay, so turns out turns out public opinion, median voter theory, right? Like whatever, does not in fact decide what politics actually is, right? Climate beliefs matter, and secondary beliefs matter, and yes, and no. Just because the average person who spends too much time on Facebook, and for some reason is in our sample here, at a time when you should no longer have been on Facebook, right? Like, that is not the definitive answer for all the obvious reasons. There are excellent political science papers to be written, not just on solar geoengineering, but on climate writ large, right? How do you move the congressional staffer to do certain things who happens to be much more important then, right? Or why did we not pass Obama-era climate policy? Because unions plus shareholders, right? There are other factors at play here. Turns out political science has also advanced since, Okay, I take your, for the record, for the, okay, sorry, okay. Sorry, what's your name?
Oh, Barb Cormenis, University of Michigan.
Hi, sorry. So there is more than the rational choice model from this textbook from the 50s. Sorry. Okay. Any more on this? Great question. Would love to keep talking about moral hazard forever, but anyone else want to derail this? Okay, cool. Okay, back to this. And okay, what do we do here? 35 minutes in. What do we do in this exercise? Okay, it's a techno-economic analysis. Yeah. Bunch of masters with spreadsheets, MBAs with spreadsheets. I will not speak ill of my students. There is excellent reasons to be doing that. For example, this is where I'm going to look at the real economists in the room now, their very first reaction at looking at this. All right, so there is this thing called elasticity, and there are excellent ways to spend, right, like estimate this for real with real data. What we do is, we look at broad data sets. We don't claim causality at all. We ignore, for example, the fact that prices matter, turns out, newsflash. As in, if there is a price signal to be sent that we do, in order to save the planet, in order to keep temperatures, we just need a whole lot more of whatever, let's call it diamond dust. De Beers is currently not optimizing for diamond particles that may or may not be useful, last time I checked. So looking at how much diamond dust is available on Alibaba is in some sense meaningless to our conversation because the industrial users are not as important and don't send the right price signal and so on and so forth. But with this, the diamonds, as an input, we can, at the very least, give order of magnitude answers now that would maybe nudge us toward one or the other. Or at least start with the, wait a second, this is the column here, as emphasized by the stars. All right, so, okay, lots of limestone out there. And we're not running out of sulfur anytime soon, turns out. At the very least, as a starting point, and again, if you ask De Beers to be simply producing more, as long as you pay them enough, they will, of course. So the fact that we don't have the right number or order of magnitude solid particles, and that these things cost 4 orders of magnitude more than the cheapest possible, may not matter in the end. But as a techno-economic analysis starting point, I think we could do a lot worse than at the very least look at a table like this and say, you know what? At the very, we can check the box. We can move on. We don't need to spend time worrying about the sulfur supply chain. Right? There are bigger problems out there. I'm sure there is a peer-reviewed article on the supply chain of sulfur and what it means to be written. it is not a first order problem. Yeah. Given, based on the nods, I did not offend anyone except for Adam. Okay. Not personally offended.
Yeah. Are you talking only when you talk about diamond? Are you talking about like mined out of the earth, or are you talking about lab-grown diamonds? Those have two very different price points, and probably will respond differently to a large demand. You also can imagine learning how to make lab-grown diamonds. The more you make them, so the cost wouldn't be as prohibitive as if you're trying to dig out more diamonds out of the ground. Right?
This is dug out of the ground. This is it doesn't. And actually, okay, so somebody who knows more about this. You famously gave Kirsten not a dug out of the, never mind, different story. Is there a, right, are there other ways to consider, so actually, no, this is not a problem, we can overcome this? Sure, right, technical progress is a thing, price signals work, and so on, right? But again, realizing that as a starting point of, wait, we ought to, at the very least, somebody's got to do this calculation. Whether or not it deserves be, ending up in a peer-reviewed paper, then I will let others to decide. There are a couple elements here, orders of magnitude, A cheaper, more available, not a problem, move on.
Sorry, I'm just,
right.
maybe I'm just completely missing something.
That's always a bad introduction to the question. So,
the worry that you're trying to address, that, in a world where we're doing a bunch of SAI that's going to...
Are there supply chain constraints of the stuff we are trying to send into the stratosphere?
Okay.
That's the question.
Then why are we... I don't understand why we're looking at demand elasticities as opposed to supply elasticities then.
Fair. So in the paper, we look at both. This was, what I showed you here was, yeah, of course, demand, sorry. So basically what we need to do, right, is figure out if we were to send a massive price signal, would we be able to unearth? So actually, you're right. What we're doing is conflating, right? What we're doing is we're looking at the equilibrium price. Yes. Yes, and turns out applied macro is a thing, right? So it turns out turns out sometimes the Excel spreadsheet, techno-econ, whatever I just called it, analysis is definitely not the definitive answer. Yes, agreed. Move on. Okay. Okay. So there are a couple other bits. Okay. So now we are right. Okay. Great. And by the way, so I should have said this. We are in the solid particle world here, right? Which actually, based on conversations earlier today, is like, wait, we knew that. Never going to work. Need to go to gases. We are very much here asking the question of, okay, we are trying to optimize for certain things. And for example, moving well beyond sulfates, again, that when one goes to more realistic size distributions of alternatives, and in some sense I'm drawing up a straw man here that says, okay, minimizing here is good, and therefore, right, some of the original diamond papers basically said one can achieve desirable outcomes here under idealized conditions. In reality, sulfur might be better once again, the purple line here. Right? And it's that kind of, okay, actually let me stick to my guns here, techno-econ-ish analysis that says, of course, we can optimize for certain things in idealized conditions, and then suddenly we go to something entirely different. in the real world, where we can't fully control, suddenly sulfur doesn't look all that bad, once again. And actually, it's that flavor of analysis that you will encounter that this paper does over and over again in essentially saying, okay, for example, not our analysis to be clear, so in some sense, quote unquote, well known to anyone who has read Joe and Chu 2021, to say that, okay, let's figure out whether the idealized, optimizing for minimized backscattering, will then work in quote unquote reality. Okay, one conclusion here. It is just very, very difficult to ensure the solid particle front that that optimized particle size can in fact be dispersed. And I don't want to make too big a deal of this, but this is where a lab experiment comes in now at Columbia, not me, definitely not me, not economics involved. Could we do this? Could we figure out how to disperse submicron particles practically? And when I say practically, very practically, there is a moving image here, yes. Is it possible for a second-year grad student in a atmospheric chemistry lab to generate the kind of particle on the one hand, and then figure out, again, in a lab setting, whether we can ensure that under certain conditions, back to basic physics, we can, in fact, disperse at the flow rate and so on, the flow rate that is needed. Fast forward, not as simple as it seems. In short, it is very difficult to send as, it's very difficult to overcome the basic physics here, to put it mildly. So one implicit assumption, and this is now, right, this is my Wick, Smith, and me paper sort of, okay, we are trying to figure out whether their existing jet engine can just do this. Well, it turns out it may not be able to. Or at the very least, coagulation is a thing. We will not be able to guarantee the particle size coming out on the other end that we think we need that would achieve the idealized conditions. And there's a lab experiment at the very least to back that up. Okay, so for example, one outcome from this exercise, and once again, sulfate is our strong man here. Sulfate aerosols are our strong man. There is a slew of different solid particles. We can test instead. Under idealized conditions, they might have better optical properties. Is it realistic to get there? And no. Short answer is, at least in, this is not Faye McNeil's lab, we at least were not able to. I'm going to say we, them, were not able to. There are increased risks with larger particles that we cannot optimize for because it's actually impossible to guarantee that the smaller particles get dispersed. I'm glad there are no technical detailed questions here because, as you can just tell from my description, I would have to defer to Faye and or Miranda to answer those questions. Okay, and just to describe this very quickly, this experiment that did happen. Are we able to model this? Are we able to figure out whether we achieve less than the sort of agglomeration that basic physics tells us would happen? And the short answer is no. Grand conclusion from this: gas is the answer. If gas is the answer, the basic calculation that techno-economic analysis of single-digit billions of dollars may not be the right answer. Why? The basic mass of what needs to be dispersed, 1 order of magnitude 35 times higher than what our at least implicit assumption was, raw amounts of material, solid particles, that ought to be lifted into the stratosphere for dispersal. Go ahead. Say again?
You have to bring the gas with you. You can't just compress the air like on an intake loft.
May I get somebody else to answer this question for me?
I really want David's answer.
Sorry, you really want David's answer?
No, I don't really want.
You don't want David's answer, okay. So the answer is yes, one can, right? There are ways to optimize. I think. Yes? Is it possible to... So here's my... Okay, I won't rely on your answer. So basically, so here's my question. Oh, sorry, I guess here's my take on this. Right? Is it possible to now look at this and say, wait a second, there's got to be ways to do this better? Yes, presumably. Unless somebody is nodding right now, no, because you've already done the experiment. At the very least, and again, right, this is the techno-economic aspect of this. The sort of thing that seems to be out there in the literature focuses on this bit here, the idealized version, and it turns out that at the very least, given coagulation, given certain other factors, given basic physics, that may not be achievable. All in, and this is in fact my last concluding slide, second to last concluding slide, there are assumptions going into our idealized all-in single-digit billions of dollars per year for 1 degree centigrade of global average warming. Every single one of those assumptions in the idealized scenario does in fact underestimate the true potential cost, giving, to be clear, many of you, us, lots of work to do in order to get back down to what the first-hand wavy climate econ answer has led us to believe. I'm not saying that therefore solar geoengineering writ large is not in fact a cheap, fast, imperfect potential intervention, but single-digit billions of dollars for the idealized scenario? Probably not, unless we do overcome some of these, several of these. Somebody right here's the research agenda in order of magnitude impact if and when we were to be able to overcome them, some of these challenges. And what I'm saying here as the grand conclusion is that there are some optimal parameters on the technical front that may not pan out. On the governance, the are we able to, in any way, shape, or form, and now I am looking at the two political scientists here, are we in any way, shape, or form going to be able to get to this idealized global optimal scenario ever? No. And I think we can more or less put that as the definitive no. That big question, a realistic deployment scenario, a real world deployment scenario. How far off is that? Well, actually, that's the question I would want to discuss in the last 5 minutes now, which is it at all realistic for us, writ large, to be in any way, shape, or form talking about the lowercase optimized technical scenario in a world where no, we are not ever going to get to the globally optimized, in a broad sense, coordinated deployment regime, governance scenario, whatever else. Are we going to be off by orders of magnitude? Are we going to be off by enough for it to matter in what we consider to be the particle of choice, the gas of choice, and so on, the method of choice? In that case, I would say definitive yes. And, well, let me pause here. Go ahead.
This is not my presentation, but we should talk afterwards because I am, not now, not in 5 years, not in 10 years, but I am cautiously optimistic that coordinated governance is possible even in the interest of powerful countries that could unilaterally deploy. And we can talk about that if you have time to.
I like your optimism. Yes, I would love to talk to you.
So your paper looked at broad multilateral coordinated governance and not some sort of mini-lateral coordinated scenario, right?
Our paper implicitly assumed broad multilateral coordinated governance. Yes. Right? And yeah, I think that's important. Right? Implicitly assumed as in there is a world where one can at least approximate the lowercase optimized deployment scenario. And yeah, that necessitates the quiet tolerance of, let's say, the coalition of the willing, the group of countries that are going to do this. It does not assume that, right, and therefore there needs to be a vote of 180 countries in some democratic whatever. That never exists. Of course not. But yes, it implicitly assumes that whatever it is that we use as a deployment scenario gets us to this world. Close enough, which is where your cautious optimism comes in, presumably. A couple of minutes.
Yeah, I guess a logistical.
Wait, less hair. Hi, Pete.
I'm lurking in the back there.
Okay, go.
Yeah, just kind of a logistical, geopolitical thing.
Wait, even less hair. Sorry. But,
Did you consider the geography? Because if you're going to release sulfur or whatever it is in the stratosphere,
Yep.
there's different places in the stratosphere.
turns out.
And the southern hemisphere is a little thinner on places than the northern hemisphere.
Turns out.
Something you factored in when thought about.
Wait a second. Okay, so we've had lots of conversations about so. I mean, yes, it is. Okay, so the short version is no, because implicitly we assumed, right? Okay, this is plus or minus 15 degrees and so on, right? There are certain assumptions. And yes, plus or minus 15 spans the continent of Africa and so on, right? And yes, the southern hemisphere is thinner. On the other hand, okay, it doesn't matter where around the globe that happens, up to a first approximation. So the short answer is no, we did not.
That's because you focused on 15, 15 rather than, if you go into 50 or 60, it gets a lot different.
Yes. And no, we did not. Actually, I'm pretty sure, I'm 99% sure we are mentioning that, yes, and by the way, that too is a factor. And yes.
So you started with free rider.
I did.
I was wondering, you showed us that in techno-economic sense, it is 35x more expensive. At what dollar point value do you think SEi does not become a free rider problem?
You mean free driver? So yeah, fair enough. Yeah, whatever. Yeah, yes, same thing. Yeah. I can't give you a dollar figure, of course. Equally important. So that free driver in the extreme in Weitzman's sort of model, 2014 I think when it came out. It is literally the assumption that it is free in the extreme sense. Well, it's not. Right? It is single-digit, low double-digit billions of dollars per year. Actually, if we did do this calculation at some point, was it 60, 65, 70 or something nations whose military Air Force budget alone is at least 3x that figure. Right? Okay, this is very hand-wavy calculation, but it is saying that, okay, there's a few dozen countries out there. Right? It does not take a global coordinated, massive fundraising and so on and so forth. Individuals may not be able to or are not able to in many ways. There are many, many governments out there that have enough money to be doing this if they wanted to? Yes. So it's a different flavor of the free driver problem. And again, right, so of course, right, if you now say, actually, it's $500 billion, okay, now we're pushing things for obvious reasons. And no, it's not that. Does the difference between 5 and 15 billion matter? Not really. Does the difference between 5 and 50 matter? Sure. Now it's not 60 countries. I don't know how many it is. It might be only 30, only 20. And I don't think that difference matters, to be clear.
So $500 billion.
Sure, yes. Yes. Yeah, I mean, yeah, please don't force me to give you a specific number, but, I mean, okay, so, I mean, just orders of magnitude, right? Unmitigated climate change, what's the latest Greenstone et al. Cost studies? Sorry. Forget Michael, he's not here. What's your, like, social cost of carbon, right? Order of magnitude. Not Bilal and Kensick, but the real work on this. We're like in the $200, right? So, okay, you add this up into, okay, low double-digit trillions of dollars of cost of unmitigated climate change. The full-on cost of mitigating climate change, like actually cutting CO2 to zero, right? Single-digit trillions of dollars. Okay, where does the free driver flavor come in? Okay, 1, 2, 3 orders of magnitude below that, as in it's just in a different category. And of course, if you now say, well, actually, we are talking 500 billion or a trillion, okay, now those two converge. Now there's no qualitative difference anymore between cutting CO2 and SRM. Right. That's the key bit here. And of course, right, so okay, it turns out many, many more things to be said here as well. This is the econ model points to edge case solution. Single-digit billions, $10 billion per year is still real money, right? For obvious reasons. Do you have time for? Actually, I have time, but yeah.
What about indirect
Go.
costs as well? Potentially compensation for harm. Do you include monetary costs? I mean, all of those also, right? Like
That is where the additional papers come in on this, and yes, they add cost. Now, okay, on that, actually, we can more or less say definitively, like, so monitoring, no, not prohibitively expensive. Vast majority of risks, okay, actually, let me end on this quickly. So, benefit cost analysis, so the typical thing here is not the right decision criterion. Right? I think at the very least what this says here, this very scientific slide, is that your benefit cost analysis is not the right criterion here, right? This sort of analysis, the qualitative analysis, tells us that yes, we ought to look at solar geoengineering, climate engineering, SRM, as an intervention because it has this qualitative flavor to it. It's about the risk trade-offs at the end, right? Risk of unmitigated climate change on the one hand, and yes, they are massive. There's a long right tail. And the potential negative consequences of SRM. That's the right comparison. That's what the work ought to be, not at can we minimize the, whatever it might be, $10 billion figure a year to 9.5 billion or maybe even 5. That difference doesn't matter. Right? And really the statement here, or in the link here for that matter, the entire statement is that what really defines the difference here is the narrow engineering costs, the direct costs to those doing the geoengineering. It's cheap and does not include any of those other costs. Whereas cutting CO2 emissions has the exact opposite features. Thank you.
I think that's a good point to end.
Thank you.